Okay. Sorry, recording now. Okay, let's start the class with it. So, before starting of today's lesson, I'm going to ask some questions about our previous lesson. Hi. Now tell me, hi. There are two main categories in physics. What are those categories? There are two main categories. Actually, there are a lot of subcategories, but we can divide physics into two main categories. What are those categories? I need responses from everyone. I need responses from everyone. Yes, very good, Tarusha. Very good, Shane. Yes. Then. So if we consider about those two are classical and classical physics and modern physics today. So most of our lessons are based on classical physics. In classical physics, actually there are some procedures to follow when we are going to investigate about a certain phenomena. Suppose if you are going to find a reason or if you want to investigate about a certain observation, so we have to follow a procedure. What are those steps with it? Can you? Can't you hear me? Another. Can't you hear me? Hello. Okay. So my question was, if you consider about classical physics, and if you want to investigate about a certain phenomena, so we have to follow a certain procedure. So what is that procedure? What is the name of that procedure? And what are the steps in the procedure? Can anyone tell me? Very good. All right. Yes, very good. Put okay. Then actually may we look into our first lesson. First lesson is unit and dimensions. Under the unit and dimensions, the first topic was physical system. So what is the definition of a physical system? Physical system. Can anyone tell me? What is the definition of physical system? What is a physical system? Thank you. You can unmute yourself and may discuss with me. What is a physical system? Yes, very good, Rasandeep. Others? What about others? A physical system. Physical system is a system, which has measurable properties. Measurable property or properties. Okay. Then we have discussed about physical quantity. What is a physical quantity? What is the definition of a physical quantity? Physical quantity. What is the definition of a physical quantity? Physical quantity. So I need response from everyone. I need answers from everyone. What is a physical quantity? Others. I need answers from. I need responses from everyone. Oh, Parasha. Having what is the answer? Shane. मतलब like nanti kaluttade. Okay. Okay, right. So physical quantity. Physical quantity is a property that can be measured. Put it. If there's any property that can be measured, such kind of property is called as a physical quantity. Physical quantity. So then we have divided the physical quantity into several categories. Actually, we use two criteria to categorize physical quantities. The first criteria was the way of taken measurement. The way of taken measurement. Some physical quantities can be measured directly. Some cannot be measured directly. We need to do some calculation. We need to do some calculation to get the value of that physical quantity. And okay. So based on that criteria, how many categories are there? How many classes are there? And what are those? What are those categories? Yes, 3. What are those categories? Yes, very good. Those categories are fundamental, then derived, and supplementary. How many physical quantities in fundamental category? 7. Yes. Okay, Buddha, okay. I will send the recording. Then, what are those 7 physical quantities? What are those 7 physical quantities? What are those 7 physical quantities? What are the 7 fundamental physical quantities? Length, mass, time, temperature, electric current, amount of substance, luminous intensity. Very good. Very good, Pute. Have. Okay. Now, after that, we have discussed about supplementary physical quantities, Pute. That is a special category. How many physical quantities are categorized under that category, and what are those physical quantities? Yes, 2. What are those physical quantities? Plane angle, solid angle. And what is the reason to categorize those physical quantities under that category? What is the reason to categorize those physical quantity under that category? You can unmute yourselves and may give me the answer. You can discuss with me. So what is the reason? What is the reason to categorize those physical quantities under that category? Why? What is the reason? No, පුතේ. ඒකම නෙවෙයි. Yes. Actually, according to the definition of angle, according to the definition of angle, according to actual angles can be measured directly. Angles can be measured directly. And therefore, no doubt of that thing, angles can be measured directly. Therefore, they should be categorized under fundamental physical quantities. But if we consider angles, according to the definitions, there's a contradiction. What is that contradiction? According to the definition, S equal to the r theta, then theta is equal to S/1. So, if we consider the unit of this angle, if we determine the unit of this angle, then the arc length is measured using meter, and radius also length, arc length also a length, radius also a length. Therefore, length over length. Actually, this angle, it shouldn't have a unit. But angle has a unit, no? Angle has 2 units, radians and degree. Therefore, according to the definition, they shouldn't have a unit. But the thing is, we have assigned a unit. Therefore, there's a contradiction in the definition of angles. Therefore, due to this contradiction, angles are categorized under separate category. Okay, actually, if not, they should be in the fundamental physical quantity. But it is they are not categorized under fundamental due to this reason, due to this contradiction. That is the first category. Then the first criteria. Then we have used another criteria. We have categorized the physical quantities according to their properties. Actually, we have considered 3 properties. What are those 3 properties? Magnitude, direction, and unit. Magnitude, direction, and unit. Therefore, availability of magnitude, direction, and unit. We can categorize physical quantities into 3 categories. So if you consider about a physical quantity, definitely it is a measurement. It is a measurement. because according to the definition of physical quantity, it is a measurable property. That means it has a measurement. Therefore, any physical quantity has a magnitude. Other than the magnitude, we can consider another two properties. Those are the direction and the unit. Therefore, based on these three properties, we can categorize the physical quantities into three categories. The first category means physical quantities which have magnitude, direction, and a unit. Magnitude, direction, and a unit. If any physical quantity has a magnitude and direction, we call it as a vector. Vector. Therefore, those physical quantities are called as vectors. Then we have categorized another two categories. What are those? Physical quantities that have magnitude and unit only. Magnitude and unit only. First category is magnitude, unit, and direction. The second category is physical quantities which have magnitude and direction, magnitude and unit. The third one, some physical quantities has only a magnitude. Some physical quantities has only a magnitude. And those are the three categories of physical quantities based on their properties. These two categories do not have a direction, a specific direction. Therefore, these two categories are called scales. Scalars. This is called vector. Then there's another question. My question is, can you give me some examples for the physical quantities that have only a magnitude? Physical quantity that has only magnitude. Give me some examples. Yes, refractive index, efficiency, yes, very good. Efficiency, Pute, very good. What else? Or relative density, yes, relative density, very good. Yes, very good. Relative humidity, yes, very good. Coefficient of friction, very good. Okay. Very good. Okay. That was our last part of previous lesson. Hi. Now we are going to do the second part of the unit. Second part of the first unit. That is about units. Now we are going to discuss about units. We have defined physical quantities. Now we are going to define, or now we are going to study about units. What is a unit? What is a unit? Can anyone tell me what is a unit? Actually, you have no, you know this thing, in all levels, you have deal with several kind of units. Then tell me, what is a unit? What is a unit? Yes. Look at, may I look into the, please, may I look into the whiteboard? Suppose now this is a rod. Now this is a rod. Okay, now you are asked to measure the length of this rod. Now I am asking you to measure the length of this rod. Suppose now you don't have any meter rulers, any ruler, then okay, then you are going to measure this distance using your palm. Okay. Then, so that is not a unit. Therefore, one student measures this length. Then he tells it has 3 units. It has 3 units. 3 units. According to his palm, the length of this rod is 3 units. Now, another student measures. He tells, no, sir, it has only 2 units. It has only 2 units. Who is correct? One student says the length of this rod is 3 units. One student says, no, it is not 3, it is 2. Who is correct? Who is correct? First student or the second one? Huh? How the hell? Are any other? There. Anita? I need response from everyone. Actually, I need to discuss with everyone. Therefore, when I'm asking the questions, please participate with me. Please give answer. Please give answer. No matter whether it is correct or not. That doesn't matter. Okay? I'm not going to laugh on it. Therefore, give answer. Be participate. Both are incorrect. Okay. Chris? Harini? First try. Both. Vasandi? Yeah. Actually, with respect to those persons, with respect to those 2 students, we can say both are correct. But the thing is, relative to that person, they have done a accurate job. But that measurement is relative to that person. Therefore, we got different values. Therefore, we cannot get an idea. We cannot get a idea to make decisions using such kind of measurements. Although we have measured this Broadpute, those measurements are useless because we cannot use those measurements to make any decision. Why? What is the reason? What is the reason? What is the reason? Although we have measured that thing, we did not measure that thing according to the standard scale. According to the standard scale, we did not measure that thing. Okay. Therefore, any measurement has to be taken relative to a standard scale. Relative to a standard scale. That scale should be independent of person. Person to person, that scale cannot be changed. Therefore, any measurement should be taken according to a standard scale. That scale is called a unit. That scale is called a unit. Therefore, if it is a standard unit, it shouldn't be depend on a person. Okay, therefore, any measurement has to be taken according to a relative to a standard scale. That scale is called a unit. Okay, is that clear? If it is clear, please raise your hand. There on the side. Okay. Now this is a length. Now tell me, you actually you know this kind of scales. Now tell me, what are the examples? What are the examples of such standard scales which are used to measure length? What are the examples, such kind of standard scales which are used to measure length? Yes, we can use meter scale, then what is feet, then miles, what else? Yards, yes, yards, yes. Meter scale, then miles, yards, feet. Actually, I am not mentioning millimeter and kilometer because that is also meter scale. Meter scale, but it has a prefix. I will let you know. So those are some specific standard scales which can be used to measure length. So those are called units of length measurements. Units of length measurement. Therefore, units means those are the standard scales that can be used to measure. Used to take measurement. Therefore, sorry, another example, mass. So if we consider about mass, can anyone tell me what are the standard scales? What are the standard scales that can be used to measure mass? Yes, kilogram. No, feet means not our feet. Feet means a feet with a ruler, 30 centimeter. Feet කියලා කියන්නේ පුතේ මේ අපේ මේ 30 centimeter. 1 feet is equal to 30 centimeter. Okay. Not our feet, okay? අපේ කකුල් නෙවෙයි. Feet means not our feet. Feet means a 30 centimeter. හරිද? Did you get my point, Putin? Yes, pound. Yes, pound. Pounds. Is that clear? Feet means that is not our feet, human feet. It is equal to 30 centimeter. It is a ruler, Putin. You know ruler? අපි කියන ruler කියලා කියන්නේ. අඩිය. feet. හරිද පුතේ? තේරෙනවද? Okay. Okay, those are some special scales that can be used to measure these physical quantities. Therefore, a unit is a standard scale that can be used to measure a physical quantity. Actually, we should define a standard scale. We should measure a physical quantity relative to a standard scale. And that scale is called the unit. Actually, there were a lot of physical. There were a lot of unit system in the world. There were a lot of unit system in the world. So if you take all book, and all book, then all mathematics or any physics or any such kind of book, you can clearly see lengths. Lengths were measured in feet or miles. Sometimes the velocity is given miles per hour or kilometer per hour, and sometimes lengths are given by feet. And therefore, if we took an all book Pute, actually, there are a lot of different units Pute. And so if you are given a question based on such kind of unit, actually it is very hard to calculate. Okay? Because those all units are not very user-friendly units. Okay, but in our all world, there were a lot of unit system. You have to remember some examples. One unit system is SPS system. Actually, in ancient time, in all physics, a unit system is named according to the units which are used to measure length, mass, and time. Because length, mass, and time are the main three physical quantities among 7 fundamental physical quantities. There are 7 fundamental physical quantities to put in. There are 7 fundamental physical quantities. Among those fundamental physical quantities, mass, length, and time. Those are the main three. Therefore, in all physics, a unit system is named according to the units which are used to measure those 3 physical quantities. Therefore, FPS means the order is for the length, mass, time. The order is length, mass, time. හැමදේම order එක length, mass, time කියන එක. Therefore, FPS system means in FPS system, feet is used to measure length. Pounds was used to measure mass. S means with the seconds. Seconds was used to measure time. Therefore, in FPS system, length was measured by feet. Then mass was measured by pounds. Then the time was measured by second. Is that clear? If it is clear, please raise your hand. This is FPS system. FPS system. FPS system. Clear na tusan pude? Okay. Then the second one. CGS system. You can write it as simple or you can write it as capital. So in CGS system, this is length. Length is measured by centimeter today. That is why it is mentioned as C, centimeter. Then mass is measured by gram. Then the time is measured by seconds. Time is measured by second. Centimeter, gram, second. Centimeter, gram, second. So if you are going to measure a physical quantity using these units, then that unit system is called CGS system. This is FPS. Then the third one. MKS or MKS only. In MKS system, length is measured by meter. And means meter. And you have to remember every time the order is length, mass, time. That is the order. Length, mass, time. Length, mass, time. Length, mass, time. Therefore, length. Here, mass. Mass is measured by kilogram. Then the time is measured by seconds. Time seconds measure. Okay. Those are some all unit systems with it. Unit systems. Is that clear? Clear, Atusan? Okay, thank you very much. Okay, good. But when we are going to deal with this unit system, actually we face some difficulties when we are going to converting one physical system, one unit system into another one, when we are going to calculate some measurements, those are relatively hard to memorize or relatively hard to do calculations. Therefore, a standard unit system, which is more user-friendly was required with it. Therefore, after doing lot of experiment, scientists have introduced a special unit system, Pute. We call it as SI unit system. That is the standard unit system in the world currently. Therefore, we have to study about SI unit system after that. So those are some ancient unit system. After that, after doing a lot of experiment, now we found SI unit system which is more user-friendly than the previous one. Therefore, the next one is SI unit system. Therefore, this is the main unit system, or this is the standard unit system currently actually we need to this is a standard unit system. This is the standard unit system we have to use in our universal calculations. That means if you are going to express any mathematical calculations or anything, especially in universal context, you have to express them in this science. But in some calculation, we can use my previous unit system for that is in physics. But if suppose if you are going to write a report or anything in universal context, then definitely you have to use SI unit system. Okay, that is a standard unit system currently using in Okay, now we are going to discuss about SI unit system. SI unit system. Today, listen to me very carefully. You know, we have categorized physical quantities mainly into three categories according to the way of taking measurement. And what are those main categories, Pute? According to the way of taking measurements, there are three categories of physical quantity. What are those three categories? Physical quantity. We have divided physical quantities into three categories. What are those? Yes, fundamental, derived, and supplementary. Yes. Yes, Pute, thank you. Pute, accordingly, the SI system also categorized into three main categories. What are those three main categories? Fundamental SI unit, Then derived SI unit finally supplementary SI units. Therefore SI units also may categorize. SI units can be categorized into three categories. What are those three categories? Fundamental, derived, and supplementary. Hi. Therefore, fundamental SI units means those are the SI units which are used to measure fundamental physical quantities. Derived SI units means those are the units which are used to measure derived physical quantities. Supplementary SI units means those are the SI units which are used to measure supplementary physical quantities. Now we can look into the first one is fundamental category. We have the physical quantity. SI unit. Okay, so normally Pute, if you consider about a unit, actually any SI is not only SI unit, any unit has a symbol. Because after writing the number means that is the measurement Pute. After writing the number, we should represent which is the unit that has been used during this measurement. Therefore, every unit has a symbol. Every unit has a symbol. Okay. The first one is length. Length mass. Again, time. Temperature. Then electric current. 6. Amount of substance. 7th one, luminous intensity. Length. The SI unit which is used to measure length Pute, that is meter. So the symbol is M. Symbol is simple. M simple M simple Pute. Simple. Then tell me, what is the physical quantity? What is a unit which is used to measure mass? Mass is kilograms. Kilograms. Symbol is kg. All are simple. Actually, there is no space between K and G. Time is seconds. Simple. So the capital name is simple. This is simple S. All are simple. මම දැකලා තියෙන සමහර ළමයි capital S දානවා. Temperature. Temperature Kelvin. Kelvin. Here capital K. Capital K. The reason is Kelvin. This name belongs to a scientist. Kelvin was a scientist. So he's a that means this name belongs to a person. If this name belongs to a person, then the first letter will be a capital letter. Unless all the letters should be simple. All the letters should be simple. Electric current, ampere. Ampere also capital. Amount of substance, mole. Moles. Simple, MOL, simple. Luminous intensity candela. Simple C, simple D. Simple C, simple D. You have to remember this one. You have to remember this table. All right. All right. Actually, I have created the registered group, registered students group. If any name, I don't know. Actually, I have joined every students may who was registered, but somehow if I miss any students, please let me know. අවුහරි මගේ ඇල්ල තියෙනවා මට කියන්න මම රෙජිස්ටර් වුණාස ඒ වුණාට මට ඇප්ලයි වෙලා නැහැ කියලා මම ගෲප් එකට ජොයින් කරන්නම් ඊළඟට from next week onward පිටේ එහෙම කියනවා ඉතින් මොකද දැන් හැම වෙලෙම කියනනේ පුතේ එනවා කියලා තව ආවේ නැහැ ඉතින් එනකන් දන්නේ නැහැ ඔගේ වැඩේ from next week onward, you will be introduced an internet protocol. That means our website today. So from next week onward, you have to log into the our website, and through that website you can join to the classes. And you can watch the recording through that website. Website from next week onwards, you can join to the classes through the website. Therefore, no need to use the links. I will create a recurring link today. Then you can use that link. Then you have to log into the website only. Okay. So introductory video will be shared in our main group. So please watch that video very carefully and registered with the website. And අනේ පුතේ මට WhatsApp එක දාලා මගේ අර මං කිව්වා මගේ කලින් WhatsApp එක බෑන් වුණා. හරිද ඒකත් එක්ක සමහර ළමයි මම ඇත්තටම දැන් ඕගොල්ලෝ අලුත් නිසා මට ඕගොල්ලන්ගේ අර සමහර වෙලාවට මගේ කියන්නේ නම් ටික මම සේව් කරලා නැහැ ෆෝන් එකේ සමහර ළමයිගේ එහෙම වුණොත් එහෙම මට හොයාගන්න බෑ කලින් එපු මැසේජස් කොහොමද ඇත්තටම ටිකක් ඒක කවුද එව්වේ කොහොමද එව්වේ කියලා හොයන්න ටිකක් අමාරුයි ඒ තරම් මැසේජස් වලක් තියෙනවා මිස් වෙන්න පුළුවන් ඒකයි මම කිව්වේ ආයෙත් කරලා මැසේජ් එකක් දෙන්න උදේ ආයෙත් පිළිවෙල නම් එවන්න එහෙම වල පිස්සුනන මට ආයෙ පොඩ්ඩක් පුතේ මැසේජ් එකක් දාන්න. මැසේජ් එකක් දානකොට මගේ අර දැන් මම මෙසේජ් කරන නම්බර්ස් ඕනට දෙකක් තියෙනවානේ. එකක් මගේ මේ පර්සනල් නම්බර් එක අනිත් එක ක්ලාසස් නම්බර් එක. දෙකෙන් ඕනි එකට කමන්න දාන්න. හරි දෙකෙන් ඕනි එකට දාන්න. මම එඩ් කරන්නම්. මේ මගේ අර පරණ නම්බර් එකට එවන්න එපා. ඒක වැඩ කරන්නේ නැහැ WhatsApp මේකට අර. හරි. ඒක තමයි මගේ පරණ ක්ලාස් නම්බර් එක. ඒකට දැන් ඒක WhatsApp වැඩ කරන්නේ නැහැ. WhatsApp එකෙන් බෑන් වුණා මේ තව එක හදලා නැහැ අතන. Okay. So those are the supplementary assignments for the have. Then I'm going to discuss about supplementary assignments first, then derived. And supplementary assignments. Today, in supplementary category, there are only two physical quantities. And actually, if you consider about fundamental and supplementary, we know the exact number of physical quantities. That's why I use those two categories first. And the first one is unit. Sorry, unit and physical quantity. There are two categories, two supplementary physical quantities. First one is plane angle. Okay. The plane angle SI unit is radian, not angle, radian, not degree. Plane angle radian. Radian symbol is RAD. Plane angle means this one. Angle which is on a plane. Then the second one is solid angle. Solid angle. Solid angle is radian. Radian simple now. Radian means it is a unit of solid angle. What a solid angle is a three-dimensional angle. Yeah. This is a three-dimensional angle. Okay. If you clear up to this, please raise your hand. Now, we have to determine, or we have discussed about derived SI unit. Derived SI unit, student. Derived SI unit. Derived SI unit. Actually, Pute, if you consider about derived unit, derived physical quantities, Pute, there are lot of derived physical quantities. So we cannot exactly count down what is the exact amount. And therefore, there are a lot of derived physical quantities. So when you are going to assign a unit for derived physical quantity, first you need to identify what is the relationship between that particular derived physical quantity and fundamental physical quantities. Okay? ඒ කියනවා derived physical quantity එක මේ unit එක හොයන්න යනකොට you should identify the relationship between the derived physical quantity and the fundamental physical quantities. Okay. As an example, suppose now you are going to assign a unit for area. Then you have to identify what is the relationship between area and the fundamental physical quantities. Then I can identify area is equal to length into breadth or width or length into length. So after identifying the relationship, then I can assign the unit of fundamental physical quantities. Finally, I can calculate the unit of the derived physical quantity. Look at this one. Suppose if we consider about area is equal to a length into another length, no? And therefore, if you want to assign a unit for derived physical quantity, the first step is you have to identify the relationship between the derived physical quantity and fundamental physical quantities. Once you identify that relationship, you have to assign the SI unit of fundamental physical quantities, because we know that thing now. Therefore, now you have to assign SI unit of this fundamental physical quantities. මුලින්ම කරන්න ඕනේ මේක කොහොමද fundamental එකත් එක්ක තියෙන relationship එක කියලා අඳුරගන්න. Then you have to assign unit of fundamental physical quantities. This is measured by meter. This is measured by meter. Now meter into meter, meter into meter. Therefore, unit of area is equal meter square. Meter square. Let's suppose force. I force kata kan kali medium kata. Velocity. Okay. First, you have to identify the definition or the relationship between the given derived physical quantity and the fundamental physical quantities. Now tell me what's the relationship between velocity and the fundamental physical quantities. What is the relationship between velocity and fundamental physical quantities? Yes, that is a length over time. Displacement over time means that is a length over time. Now you can assign physical quantities of length, that is meter. So unit of length. The unit of length is meter. The unit of time is second. So that is equal. We have to write this one as m. You can take s into the numerator. It is s minus 1. Or You can write this one as M slash S. Slash means there is division to it. M divided by S. Okay, normally you have to write either in these two formats. So when you are writing ms minus 1, there is a space on it. I will tell you what are the rules. ms minus 1. Then force. Force. How did you define force? Force. Mass into force කරන my acceleration මෙතන හොයලා ඉන්නවා. හොඳයි. එතකොට ඔයගොල්ලෝ DC. Acceleration. Acceleration equal to velocity over time. Velocity difference means velocity difference over time. Velocity difference means that is a velocity. Velocity over time. Now you know velocity is measured by ms minus 1. ms minus 1 divided by time is measured by s. Therefore, if you take this one into the numerator, it will be another s minus 1. S minus 1 means s minus 2. S minus 2. Therefore, the unit of acceleration is ms minus 2. Then, you know, according to Newton's second law, force is equal ma, mass into acceleration. Mass into acceleration. Mass is measured by, what is the SI unit of mass? What is the SI unit of mass? Yes, kilogram. Acceleration. ms minus 2. Therefore, unit of F of force is equal kilogram meter per square second. Kilogram meter per square second. But this is not the SI unit of force method. The SI unit of force is Newton. This is equal to Newton. Therefore, SI unit of the SI unit of force is equal to Newton. So what is the reason that? What is the reason for that? Actually, to derive this equation, Newton, so Isaac Newton was the scientist who introduced this equation as well as most of those theories. Therefore, as a respect for him, we allocated his name into this unit project. That is the reason. And therefore, if we consider about the unit of derived physical quantity, if we consider about derived SI units, there are two main categories. One category, the first category is like this. Those SI units do not have any special name. Those SI units do not have any special name. And actually, these SI units are derived using the definition of the particular physical quantity. But some physical quantities like this, they have some special SI unit. This SI unit has a specific name, some special name put it, Newton. Therefore, some physical quantity, some derived physical quantities have a sign with a special name. Some have a sign without any special name. Therefore, SI unit of derived physical quantities. SI units of derived physical quantities can be divided into two categories. SI units without special names, SI units with special name. Is that clear? Now, here I'm going to give you some small questions. Have. Now write a topic. Now this is a topic. Write the main topic with the units. 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 Where is the main topic? This is the first question. So in your book, there are only questions. There will be questions only. And the first question. First one. Determine the SI units of following physical quantities. Determine the SI units of following physical quantities. Volume, density, pressure, work done, efficiency, energy. Frequency. I will send one. I will send the soft copies of soft copies of note into our registered group එකේ මම registered group එකට අපේ soft copy එක මම දානවා ඒ අතරේ මම ඕගොල්ලන්ට next week එකේ වෙනවා මොකද මම දැම්මේ නැත්තේ එකක් මට නැත්තම් දාන්න බෑ මොකද ඕගොල්ලෝ මේ අර මගේ අර message එකට response කරලා තිබ්බේ බොහොම කීප දෙනා ළමයි මම අර response කරන්න ගියා පොඩ්ඩක් අර මේ මොනවද මේ registered group එකට දාගන්න ළමයි කට්ටියව ඇත්තටම කීප දෙනෙක් කරගෙන response කරලා තිබුණේ නැහැ මේ ඊට පස්සේ අන්තිම මොහොතේ තමයි respond කරන්නේ කියන්නේ ඒවල තිබ්බේ Therefore, actually, I have created the registered group, I think, day before yesterday or yesterday. Not yesterday, day before yesterday. And, no, do not get print out. I will send the book, okay? I will send the book. No need to take print out. I will send the book. මම පොත් ටික මම ඔයාලට එවනවා. මට පොත් ටික එවන්න කලින් මට මේ රෙජිස්ටර් වෙච්ච ළමයි ටික හරියට බලා ගන්න බෑ. මොකද හැමෝටම එවන්න ඕනේ නැහැ මේක. Then frequency. Okay. Do these questions very quickly. Okay. Have a computer. නැද්ද තව computer නැහැ. Okay, volume. Volume means that is equal to length into length into length. Length into length into length. 3 lengths නේ පුතේ. Very good පුතේ. Very good. Length into length into length. That means this one is measured by meter, 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 meter. This one is measured by meter into meter into meter. That means there are 3 meters. Therefore, answer is meter cube. Meter cube. Then this one. Density is equal mass over volume. Mass is measured by kilogram. That is the SI unit of mass. Volume is measured by meter cube. Meter cube. Therefore, the SI unit of density is equal kilogram per meter cube. Then pressure. The pressure is equal force over area. Force over area is equal to pressure. I think you know this one in your laws. Now tell me, what is the SI unit of force? What is the SI unit of force? Very good, Pute. Very good. What is the SI unit of force, Pute? What is the SI unit of force? Newton. Newton. Class Pute 7:30. 7:30. Newton. Area. Area is measured by meter square, no meter square. Therefore, this one is equal Newton per meter square. Meter square. But normally the SI unit of pressure is equal to Pascal. Pascal also a scientist. This one is Pascal. Pascal, capital P, capital simple A, capital P, simple A. Pascal. Then the work done. Work done is equal to the force into displacement. Force into displacement. Force into displacement. Force. Force is measured by Newton. Displacement is measured by meter. Therefore, this should be equal Newton space meter. Space I can know. But normally the work done is measured by joule. Joule, because it is an energy. Work done is an energy today. This is measured by joule. That is capital J. Capital J put it. Capital J, joule. Joule also a scientist put it. Then efficiency. What is the assignment of efficiency? How to determine efficiency? Efficiency was one. What is the assignment of efficiency? Efficiency. How to determine efficiency? What is efficiency? කලින් නෝට් එක මතක නැහැ ඔක හරියටද? කලින් එක මතක නැහැ. ගිය සතිය කරපු එක. Yes, useful work done over total work done. Yes, useful work done over total work done, or useful output work over the total input work. The total input work. That is useful. Work done over total input work. Total work done over total input work into 100. This is a percentage. This is percentage. Therefore, work done will be measured by joule. Total input work, that's all. That also work done with it. Both are measured by joule. Both are measured by joule. Therefore, joule into joule percentage of the. Therefore, it has no unit. It has no unit. It has no unit. Is that clear? Theruna Tusan? Then energy. Energy. Actually, energy also equal to the work done. Energy also equal to the work done with it. And work done or force into displacement. And therefore, that is equal to force into displacement. Therefore, force is measured by Newton. Displacement is measured by meter pute. Therefore, the unit of energy is equal to Newton meter. But this is equivalent to joule, joules. This is measured by joules. Then frequency. Frequency. Now tell me how to determine frequency. How to determine frequency? What is the equation? What is the equation you are going to use to determine the unit of frequency? What is the equation you are going to use to determine frequency? Yes, V equal F lambda, V equal F lambda. V equal F lambda. We can use V equal F lambda. Lambda means wavelength, that is a length. This is a velocity. This is a velocity, therefore V is equal, sorry, V not V. Frequency F. F is equal V over lambda puthe. V is measured by ms minus 1 because it is a velocity. Ms minus 1 divided by lambda is wavelength. Wavelength is meter. So meter to meter will be cancelled out. Therefore, the unit of frequency is per second. Per second. Unit of frequency is per second. But it has also a special name, Pute, a special name that is hertz. Hertz. That is hertz. Hertz. Hertz also a scientist put it. Then electron, power. Power. Power, power, power. Power is equal to work done per second. Work done per second. Power is equal to work done per second. Yes, per second කියලා කියන්නේ පුතේ 1 over time කියන එක තමයි. Per second කියලා කියන්නේ 1 over time නේ. නේද? හරි මෙයාව ඔයා denominator එකට ගත්තාම මොකද වෙන්නේ? 1 over s එන්නේ. හරිද? Did you get my point? Ready? Per second. You are correct. නෑ. 1 over time කියලා equation එකක් නේ. 1 over time කියලා equation එකක් නැහැ. ආ 1 over time නෙමෙයි එතන එන්න ඕනි 1 over periodic time කියන එක. හරිද? 1 over periodic time. time නෙමෙයි. 1 over periodic time කියන එක තමයි මේ periodic time is actually period is measured by time පුතේ. 1 over period අපිට කියන්නේ. ඔය වැරදිට උගන්වලා තියෙන එක ඉතින් ඒක ඔයගොල්ලන්ට තේරෙන්නේ නැහැ ඔයගොල්ලෝ කාලේ ඒකයි ප්‍රශ්නේ. මේ 1 over time කියන එක වැරදි. 1 over period. period කියලා කියන්නේ අපි සාමාන්‍ය පුතේ ඔය ඕකේ ඉන්නේ oscillation එකක් එක්ක. oscillations වල තමයි සාමාන්‍ය ඔය frequencies කියලා දේ මනින් measure කරන්නේ. අපි oscillation එකක් ගත්තට පස්සේ period එකක් කියලා කියන්නේ එක oscillation එකක් වෙන්න ගත වෙන time එක. හරිද? if you consider about oscillation අපි oscillation එකක් හිතන්න පුතේ අපි මේ ඔය swing එකක් හිතන්න swing එකක් මෙහෙම oscillate වෙනවා කියලා හිතන්න. swing එකක් oscillate වෙනකොට if you consider about full oscillation the time taken to may do a full oscillation is equal to period. Period. Normally we call it as periodic time. And the frequency is equal to 1 over periodic time, not time. Periodic time is it's a special physical quantity. And periodic time is the time taken by oscillation to complete a full circle, full oscillation. Is that, do you know? One more time equation. That is wrong. Okay. One more time, one more periodic time or period. Power. Power. Question. Okay, power. How to measure power? How to measure power? Power is equal to yes, work done over time. Work done over time. Power is equal to work done over time. Work done over time. You know, work done. The SI for work done is joule. Joule. Work done is joule. Time is S. Therefore, unit of power should be joule per second. Joule per second. Joule per second. But that is not the SI unit of power, Putte. The SI unit of power is equal to watt. 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 Also a scientist put it. That scientist can have. Is that clear? If it is clear, please raise your hand. Okay, with it. Now, if we look into this example, now it is very clear some physical quantities. Actually, we can derive SI units using the equation for some physical quantities. Meter, density, kilogram per meter cube. So those kind of physical quantities have the exact same unit. But there are some specific physical quantities. Actually, they have some special units within. Special units with special names. Therefore, as I mentioned you earlier, we can divide the set of derived physical quantities into two main categories: units without a special name and units with a special name. So you have to remember those physical quantities, especially units with special names. Make it but as an initial step, you have to remember those physical quantities, those unit of physical quantities. Okay. Is that clear? Now we need to determine, actually, still we are under the discussion of units of derived physical quantities. derived physical quantity වල units තමයි සාමාන්‍යයෙන් කතා කරමින් යන්නේ. Okay. Now still we are under the discussion of units of derived physical quantities. Right. So, as per our previous explanation, when we are going to sorry. Okay. When we are going to determine the SI unit of derived physical quantities, the first thing you have to do is you have to determine the definition. After that, you can derive that thing. The first thing you have to do, the first thing is you have to make sure the relationship between the derived physical quantity and the fundamental physical quantities. Like this. Density. Density is equal to mass over volume. Volume means length into a length into a length. The first thing you have to do is you have to write the relationship between the derived physical quantity and the fundamental physical quantities. So using this relationship, you can derive their units put in. Using this relationship, you can derive the unit. You can derive the unit. Right? How to derive the unit? You have to assign the unit of each fundamental physical quantity into this relationship. You have to assign the unit of each fundamental physical quantity into this relationship. kg over mass, length is measured by mass put in. Therefore, length is measured by mass. Length is measured by mass. Then this is equal to kilogram per meter cube, kilogram more meter cube. Then I can write this one as kilogram per meter cube. Actually, this unit is derived using this relationship. Therefore, this kind of physical quantity is called the derived format. The derived format of SI unit. The derived format of SI unit. Every physical quantity has a unit of this format. Suppose now we are going to consider what the force. If you consider force, the force is equal to mass into acceleration. No? Okay? Mass into acceleration. Then, if we use the unit of mass, that is kilogram, this one is m s minus 2. Therefore, kilogram meter per square second. So this is the derived format of the SI unit of force. This is the derived format of SI unit of force. This is the derived format of SI unit of force. Therefore, you have to understand one thing. in some physical quantities, the derived format will be the SI unit also. Here, the derived format is kilogram per meter cube puthe. That is the SI unit of density 2 puthe. Therefore, in some cases, the derived format is equal to the SI unit of that physical quantity. But some occasions, like this, derived format is not the SI unit of the physical quantity. As in forces puthe. And in force, derived format of SI unit of force is kilogram meter per square second. But this is not the SI unit of force. The SI unit is Newton. And so that is the difference between the derived format of SI unit and SI unit. Actually, any physical quantity can have the derived format of SI unit. But that format may be the SI unit, may not be the SI unit. I don't know that thing. Other thing. So when you are going to determine the derived format of any SI unit, you have to make sure the units. You have to make sure the units in this expression. The units in this expression should be the unit of fundamental physical quantities. Methana thiyena units of fundamental physical quantity manila units when known. Those units should be the unit of fundamental physical quantities. I will give an example. Suppose you need to determine the derived format of SI unit of work done. So work done is equal to force into distance. Force into distance. So you know force is measured by Newton. Displacement is measured by meter. Newton meter. This is not the derived format. Because Newton is not a unit of fundamental physical quantity. Therefore, this is not a derived format. This is another new unit. Make a unit. Make a SI unit. This is not a SI unit. This is not a derived format of SI unit. This is another unit. This is another unit which can be used to measure work done. So, but this is not the derived format. This is not the derived format. If it is derived format, definitely all the symbols should be related to fundamental physical quantities. Is that clear? If it is clear, please raise your hand. So if we need to determine the derived format, then you have to convert Newton into kilogram. Newton is equal to this one. Kilogram meter s minus 2. Newton is equal to this one. Therefore, you have to apply kilogram meter s minus 2 instead of Newton. Therefore, you can determine this derived format. To do that, you have to remove Newton by this one. Kilogram meter s minus 2 into meter. Then there are 2 meters. Then it will be meter square. Therefore, the answer is kilogram meter square s minus 2. So now you can clearly see these symbols relate to fundamental physical quantities only. Therefore, this is the derived format of SI unit of work done. This is the derived format of SI unit of work done. Is that clear? This is not a derived format. This is the derived format. I need responses from everyone. If any student did not get my explanations, please raise your hand. Okay. Okay. Shane, do you have any question? Have. Okay. Okay. So, if we consider about physical quantities, physical quantity, actually, the one consider about derived physical quantities. Okay. Every derived physical quantity has a special formula to derive that physical quantity. And derived physical quantity අනිවාර්යෙන් special formula එකක් තියෙනවා. So using that formula, I can get the derived format. I can get the derived format of SI unit. And as well as I can assign the SI unit too. Because sometimes SI unit may not be equal to the derived form. It may be changed. Force. If we consider force, formula is F equal MA. This is kilogram MS minus 2. Therefore, the derived format of SI unit is kilogram MS minus 2. But this is not the SI unit of force. The SI unit of force is Newton. Newton. Anyone? Work done. Work done or energy. Work done is equal to force into distance displacement. Force into displacement. The force is measured by Newton. This is measured by meter. But Newton meter is not a derived physical quantity. I mean, derived SI unit, okay? Derived format of SI unit. Because Newton is not related to fundamental physical quantities. Therefore, this one should be converted as kilogram MS minus 2. Kilogram MS minus 2. Then there are two ends. This is equal to m square S minus 2. Therefore, derived format is kilogram m square S minus 2. So this is the derived format of SI unit, but that is not the SI unit of work done. The SI unit of work done is joule. Joule. Then third one, density. Density D is equal to mass over volume. Mass over volume. So mass is measured by kilogram. Volume is measured by meter cube. Therefore, direct format is equal to kilogram per meter cube. So what is the SI unit of density? The SI unit of density? The SI unit of density? That is also equal to the direct format put A. That is also equal to the direct format. Therefore, now here density, the derived format of SI unit of density is equal to its SI unit. Area. Area is equal to a length into a length. Then the derived format is meter into meter to the meter square. Derived format is meter square. SI and also it is square. Then fifth on power. Power P is equal work done over time. Today, work done. If you can understand work done, the derived format is kilogram meter squared S minus 2. Kilogram meter squared S minus 2. That is the derived format. Time is S. So if you take this time into the denominator, it will be minus. Therefore, there are another minus 1. There's another minus 1. Therefore, now the total minus should be 3 minus. Therefore, derived format of SI unit is equal kilogram meter square S minus 3. S minus 3. SI unit. SI unit of power. SI unit of power is equal to what? What? So look at this table, Pute. Now look at this table. You can clearly see some physical quantity. Some physical, if you have some physical quantity, the derived format of SI unit is equal to the SI unit. But in some physical quantities like this, derived format is not matched with the actual SI unit. The actual SI unit is another one. Actually, most of the cases, it might be a name of a science. And is that clear? Clear or not, Ussan? If it is clear, please raise your hand. I need response from everyone, Pute. But if you did not get this thing, please mention it. Okay. Okay, you have to remember one thing. Nah, Pute, that is wrong. එහෙම නෙවෙයි. අපි ස්පෙෂල් නේම්ස් දීලා තියෙනකොට ඒ ෆිසිකල් ක්වොන්ටිටිය හොයන්න. නැත්නම් ඒක මොකක් හරි මේ ඒ ගැන මොකක් හරි එක්ස්පෙරිමන්ට්ස් කරපු සයන්ටිස්ට් කෙනෙක්ගේ නමට. හරිද? දැන් අපි ස්පෙෂලි ගත්තොත් එහෙම දැන් ෆෝසස් ගැන ගත්තොත් එහෙම නිව්ටන් ඒ ගැන එක්ස්පෙරිමන්ට් කරි. ඒ ගැන එක්ස්පෙරිමන්ට් කරලා ඒ ගැන ෆෝසස් හොයාගෙන ඒ ගැන සෝරි ඒ ගැන මේ ඉන්වෙස්ටිගේට් කරලා ඒක තනි කරම හැන්ඩල් කරේ නිව්ටන්. හරිද? ඒක නිසා එයාට රෙස්පෙක්ට් එකක් දෙන්න ඕන නිසා තමයි නිව්ටන් කියලා කියන්නේ. එහෙම නැතුව මෙයාගේ නෙත් එක වැඩි නිසා එහෙම නෙමෙයි. මෙයාගේ නෙත් එක වැඩි නිසා නෙමෙයි. there are a lot of physical quantities with very lengthy units පුතේ. හරිද? ඔයගොල්ලන්ට හම්බ වෙනවා නේද? There are a lot of physical quantities with very lengthy units. But normally we give a special name as a respect for the scientists who investigate about that physical quantity. And that is the only reason. That is the only reason. හරි? දිග වෙවන්නේ ඒක වැරදි. හරි question එක හොඳයි. Okay. Is that clear? If it is clear, please raise your hand again. Okay. Therium the theory இல்லையது නැත්තම් கொஞ்சம் 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 ஸ்டேட் இன் கட்டிනවා. Half okay, half okay, half not okay, half okay, half not okay கட்டிනවා. No. Okay. Now it's May 5 o'clock today. So you can take a small break. You can take a small break and come back again at 5:30. Then we will start prefix, as well as unit conversion. After that, dimensional analysis. Therefore, the second part will be very interesting part as well as relatively hard part. Okay. So, please come back at 5:30. You can take a break and come back at 5:30. Okay. Shall I start? If I had the class, please give me a thumb. Thank you. Hi. සාමාන්‍යයෙන් මම වෙලින් කියනවා වගේ විදිහට අපි මම හරි කැමති වෙලාවට වැඩ කරනවා නම් ඒක ගොඩක් හොඳයි. මොකද මේ ටයිම් එක වැඩ කරේ නැත්නම් තේම එකක් ඒක අපි උරු වෙන්න ඕනේ මුලින් ඉඳලම ටයිම් එක වැඩ කරන්න. මොකද මේ ඔයාලා අනිවාර්යෙන් හොඳ ප්‍රොෆෙෂනල්ස්ලා වෙන්න යන්නේ. හරිද? ඒ කියන්නේ නිකන් මෙතන නවතින්නේ නැහැ. ඔයාලා මේ ෆීල්ඩ් එක කරන්නේ මොකක් හරි හොඳ ප්‍රොෆෙෂන් එකකට යන්න. මොකක් හරි හොඳ ප්‍රොෆෙෂන් එකකට යනවා කියලා කියන්නේ තේ ටයිම්ලි වැඩ කරනවා කියන එක මස්ට් එකක්. Is a must. ඔයාලට දැන් අපි මේ මොකක් හරි මේ ડોක්ටර් කෙනෙක් ගත්තොත් එහෙම දැන් ડોක්ටර් කෙනෙක් කියන්නේ තනිමානේ පුතේ ඔයාලා වෙලාවට මේ ලිඩික් ගාවට යන්න බැරුණොත් සමහරට ඒක මාරම රෙස්පොන්සිබිලිටි එකක් වගේ. සමහරට ඒද නැති වෙන්න පුළුවන්. වෙලාවට යන්න බැරුණොත්. ඒ වගේම තමයි දැන් ඉන්ටර්වියුස්ලා වගේ ගත්තොත් එහෙම අනිකරම මේ අර හොඳ ප්‍රොෆෙෂනල්ස් කෙනෙක් ඉතින් ඒ වගේ වෙලාවට ගත්තොත් එහෙම අපි අනිවාර්යෙන් මීටින් එකක් නම් ඒ වෙලාවට මීටින් එකට යන්න ඕනේ. මොකක් හරි ඒකේ ටයිම්ලි වැඩ කරනවා කියන එක මාරම විදිහට බලන ප්‍රොෆෙෂන්ස් දෙකක් සහ ඒ කියන්නේ ඒක අපේ පර්සනැලිටි එකට තනිකරම වැදගත් වෙන ප්‍රොෆෙෂන්ස් දෙකක් මේ ඉන්ජිනියරින් එක මෙඩිසින් කියලා කියනවා. ඒ කියන්නේ ඒකේ තියෙන ඕනිම ෆීල්ඩ් එකක් ගත්තත් timely වැඩ කරනවා timely තමුන් අර ෆන්ක්ෂනල් ටික කියන දේ මේ මාර්ගම වැඩගත් වෙන ෆීල්ඩ්ස් දෙක. හරිද? ඒ කියන්නේ මාත් තාමත් මේ ෆීල්ඩ් එකේ ඉන්න නිසා මම කියන්නේ මේ ඔක මේ තේරුම් ගන්න එක අත්‍යවශ්‍ය දෙයක්. ඔය ගොඩක් කට්ටිය කියන විශේෂයෙන් අලුතෙන් එන ට්‍රේඩර්ස් වලට එහෙම ඇත්තටම මේ ඒක හරියටම තියෙනවා මොකද ඒක තමයි ඔයගොල්ලෝගේ පර්සනැලිටි ඉස්සරහට යන. ඒ කියන්නේ ඒක වාර විදිහට ඔයගොල්ලෝගේ පර්සනැලිටි බලනවා. ඒ කියන්නේ මොකක් හරි වැඩ දුන්නොත් වෙලාවට කරන එක. මොකක් හරි මොකක් කරවා ටයිම් එකක් දුන්නොත් වා ටයිම් එකට වැඩ කරනවා කියන ඒ රෙපියුටේෂන් එක හැදෙනවා කියන්නේ මාර වැදගත් දෙයක්. ඒක පට්ටම වැදගත් දෙයක්. හරි. ඒක පොඩ්ඩක් හදා ගන්න. මේ පොඩි බාල කට්ටත් එක්කම ගියේ. මේ හොඳයි. හරි. වැඩේ පටන් ගමු. ඕකේ. හරි. ඔකට ඉන්න කමන්නේ වැඩේ පටන් වෙන ගමන් දෙයක් නෑ. මේ වෙලාවට පටන් ගන්න ඕනේ. හරි. Okay, Puti. If you consider about the previous lessons, we have discussed about units. So we can summarize the things we have learned in that lesson, Puti. So if you consider about units, actually there are several unit systems. There are actually we have discussed about 3 unit system. One is FPS, then CGS, NKS. Then we have discussed about SI unit system. Therefore, those are the unit systems. There's a first note or first summary in systems. Then we have actually we have discussed each and every unit system separately, but we have discussed about SI unit systems deeply. So if I consider by SI unit systems, SI unit system, there are 3 categories: fundamental, supplementary, and derived. Derived SI can be further divided into 2 categories: SI unit without special names and SI units with special names. SI units without special name and with the special names. And so if we consider about SI unit with the special names, most of the cases they are based on some name of scientists. Then we have discussed about derived format. Derived format of SI unit. Okay, derived format of SI unit. It is a separate thing. It is a separate thing. Okay. Actually, those are the things that we have discussed under the unit segment. Although actually some actually we have discussed about how SI units. Actually, although there's a SI unit for particular or certain physical quantity, we cannot use that SI unit to measure every measurements. That means you know the SI unit of length. The SI unit of measuring length is meter. But we cannot use meter to measure every length. That is impossible. Okay. I will give you some example. Now, you need to determine the distance of atomic radius. You need to determine the distance of atomic radius. Can you use a meter ruler to measure the distance of atomic radius? Can you use? Can you use a meter ruler? No, you cannot use. No, that is impossible thing. You cannot use a meter ruler to get the distance of atomic radius because that is a very, very small value. That is extremely small value. On the other hand, can you use a meter ruler to measure the distance from the Earth to Sun or Earth to another star in another galaxy? Can you use a meter ruler to measure? No, you cannot. Therefore, although there is a standard unit, that unit may not be sufficient or may not be practical to measure some special sizes of unit, sizes of measurements. And because some measurements are extremely small, some measurements are extremely large. Therefore, due to this reason, the defined standard unit may not be suitable to measure such kind of extremely small or extremely large scale measurements. Is that clear? If it is clear, please raise your hand. Tevara Tussan. Therefore, we cannot use the standard scale to measure such kind of measurements. So, in such cases, we have to convert the standard scale to a very small scale or to a large scale. The same scale has to be converted into a smaller one or a larger one to measure such kind of measurements. Okay, I will give you some example. Okay. Now, suppose now we have to get the measurement of extremely small measurements and extremely large values. So in such cases, as we discussed earlier, in such cases, the SI may not be sufficient. Therefore, the defined SI should be converted into a smaller unit, a smaller scale, or a large scale. They should be converted into a small scale or a large scale. We should convert it into a small scale to measure a smaller measurement. we should convert the SI unit into a larger scale to measure larger measurements, to measure larger measurements. Now, how to convert it? How to convert it? How to convert the SI unit into a smaller value or a smaller scale or into a larger scale? How to convert it? How to convert it? Look at this somebody. We can take this current as meter. This is the SI unit. If we need to convert this SI unit into a small scale, we should divide the scale by a suitable value. We should divide the SI scale by a suitable value. That means this is something like this. Suppose now this is a meter scale puthe. This is 1 meter, and suppose this is second meter, and suppose this is third meter. Okay. So if there is an object, like this, can you measure the length of this object using this scale? Can you measure the length of this object using this scale? So this is a meter scale. This is 1 meter, second meter, third meter. And now there's a small object like this. Can you use this scale to measure the length of this object? Can you measure? Can you use what? Oh, I didn't do a responses. Oh, I need responses. Okay, can you use this scale to measure this object? May object measure කරන්න scale use කරන්න පුළුවන්. So in such cases, what should I do? In such cases, what should I do? Yes, very good share. So we can divide this meter. This is meter scale. We can divide this scale into a suitable number of divisions. We can divide this scale into a suitable number of divisions. We can divide this scale into a suitable number of divisions. And then it will be converted into a smaller scale. If I divide a scale by a suitable number, it will be converted into a smaller scale. Initially the scale was meter by meter, but after that, suppose I have divided this into 1,000 divisions. Suppose I have divided this into 1,000 divisions. Initially in between two divisions, the length was 1 meter. Now, in between two divisions, the length is 1 over 1000 meter. That means 0.001 meter. Yeah. So, by dividing a scale into suitable divisions, I can make a smaller scale. Is that clear? Theory. If it is clear, please raise your hand. By dividing a scale, we can make a smaller scale. And therefore, if we consider SI unit, if we divide this SI unit into a suitable divisions, we can convert it into a smaller scale. As an example, because I'm giving this example, you know this thing. So if we divide the meter scale into 1000 divisions, what will happen? It will be converted into 1 meter. If I divide 1 meter by 1000 division, it will be converted into millimeter scale. That's no expression. Is that clear? If it is clear, please raise your hand. Then, on the other hand, suppose now we are going to measure a distance between two towns. So in such cases, we cannot use meters, no? Normally we use kilometers, no? So in such cases, the meter scale should be converted into a large scale. Therefore, in such cases, the SI unit should be multiplied by suitable number. Here the SI unit should be divided by a suitable number. Here it should be multiplied by a suitable number. If it is multiplied by a suitable number, it will be converted into a large scale. As an example, if I multiply this by 1000, if I multiply the meter scale by 1000, it will be converted into 1 kilometer scale. It will be converted into kilometer scale. Is that clear? If it is clear, please raise your hand. Therefore, Pute, a SI unit, actually, as a summary, Pute, SI unit. Although there's a SI unit for particular or certain physical quantity, that SI unit might not be suitable to measure extremely small or extremely large values. So in such cases, we should convert the SI unit into a smaller scale or into a large scale. So how to convert the SI unit into a smaller scale, Pute? By dividing a suitable number. How to convert the SI unit into a large scale is by multiplying a suitable number. හරි පුතේ ඒක තමයි මේ ආසරයක් මම මතක් කරේ. දැන් ඔය ආසරයක් මතක් කරේ මේ මොකද්ද? අපි ගත්තොත් එimhe assignment එක ගත්තොත් එimhe assignment එක හැම measurement එකක්ම measure කරන්න suitable වෙන්නේ නැහැ. ඒක small scale වලට සහ large scale වලට වෙන වෙනම අපි ඒක කරගන්න ඕනි. ඒ කියන්නේ convert කරගන්න ඕනි. ඒ කියන්නේ small කියන්නේ ගොඩාක් පොඩි value එකක් measure කරන්න අපි small value එකක් දාගන්න small scale එකට යන්න ඕනි. ගොඩාක් ලොකු value එකක් measure කරගන්න අපි large scale එකට යන්න ඕනි. example එකක් විදිහට ගත්තොත් එහෙනම් අපිට meter රූල use කරන්න බෑනේ පුතේ atomic radius එහෙම වනින්නේ නේද? ඒ වගේ meter රූල use කරන්න බෑ අපිට නිකන් අර මේ planets දෙකක් අතර තියෙන distance වනින්නත් නේ. අන්න ඒ වගේ is extremely low value or extremely large value cannot be measured using the standard scale. So we have to convert this standard scale into a small scale or into a large scale. And, so in such cases, a SI unit can be converted into a small scale by dividing a suitable factor. A SI unit can be converted into a large scale by multiplying a suitable factor. So this is the factor. This is the factor which is used to convert the SI scale into another scale. Is that clear? If it is clear, please raise your hand. Again, I will do this one. Therefore, SI unit can be converted into a larger scale by multiplying with a suitable factor. It will convert it into a large scale. So as it is a multiplication, Pute, we call this factor as multiples. We call this factor as multiples. Then we can convert the SI unit into a smaller value, a smaller scale. We can convert the SI unit into a small scale by dividing by a suitable factor. So dividing means put multiplication with reciprocal. No? Dividing means it is equal to multiplication with reciprocal. And as it is a multiplication with reciprocal, we call this factor as submultiples. Submultiples. So as an example, if I consider about meter, if meter scale is multiplied by 1000, it will be converted into a kilometer scale. It will be converted into the kilometer scale. If meter scale is divided by a suitable factor. If meter scale divided by a suitable factor, that is 1000, this is equal to multiplication with reciprocal. It will be converted into a small scale. 1 millimeter. Is that clear? If it is clear, please raise your hand. තේරුණා තුස්සන් මොකද මේ කරන්නේ? තීලින නේද? පුතේ තීලින තේරෙනවද? තීලිනක්ද තීලියාවද නැහැ. තේරුණාද? Okay. Suppose now we have to suppose we have to convert a scale. We have to convert a SI scale. But SI scale la convert කරන්න තියෙනවා කියලා හිතන්න. Now we have to convert SI scale. Suppose now I have convert this SI scale into a large scale. Suppose I have multiplied by 1000. Today, if you converted the SI scale into a large scale or a small scale by using a suitable factor, that factor should be notified. It should be symbolically notified. It should be symbolically notified. So to notify that factor, we use English letter. We use English letter. We use an English letter in front of the SI symbol. We use a English letter in front of the SI symbol. So that letter is called a prefix. This letter is called a prefix. Prefix. අපේ නමක් තියෙනනේ පුතේ යාගේ තමයි. නම ඉස්සරෙන් තියෙන කෑල්ලනේ පුතේ prefix එක කියන්නේ. Hi. So prefix means so if I convert a SI unit into another scale, that factor which is used to convert the SI unit into the particular scale, it should be notified. It should be notified. How does it may notify? It is notified by an English letter. It is notified by an English letter which is written in front of the SI symbol. So that English letter is called prefix. Is called prefix. Is that clear? තේරුණා තුස්සන්නේ. මොකද්ද මේ prefix එකක් කියන්නේ කියලා? I need responses from everyone. But හැමෝගෙම responses තියනවා නම් හොඳයි. එහෙනම් prefix එකක් කියලා කියන්නේ මොකද්ද පුතේ? අපි SI unit එකක් convert කරගත්තොත් වෙන unit එකක් විදියට. ඒ කියන්නේ SI unit එක if I SI unit එකක් large scale එකකට හරි small scale එකකට convert කරොත් ඒ convert කරන් use කරපු factor එක අපි mention කරන්න ඕන. ඒ factor එක mention කරන්නේ මේ SI unit එකේ symbol එක තියෙනවානේ. ඒ symbol එකට ඉස්සරහින් ලියන මොකක් හරි English letter එකකින්. ඒ symbol එකට ඉස්සරහින් ලියන letter එකක් නිසා අපි letter එකට කියනවා prefix එකක් කියලා. Prefix. Therefore prefix is a English letter which is written in front to the SI symbol, and that represents the factor which is used to convert this SI unit to the particular scale. Okay. So, if we consider about prefix, there are two categories. One is multiples. Other one is sub-multiples. And so, actual fact in these cases, in these two cases, factor is 1000. Factor is 1000. But that factor is used in different ways. Here, the factor is multiplied with the scale. Here, the scale is divided by the factor. Therefore, we do not use the same prefix. We do not use the same prefix. Otherwise, how to identify whether it is divided or may multiply? Therefore, we have to use two different prefixes. So, if you consider prefix, if you consider prefix pute, it is divided into two categories. One is multiplus, other one is submultiplus. Metric ton කියලා කියන පුතේ වෙනම යුනිට් එක. ඒක වෙනම කතන්දරයක්. ඒ කියන්නේ there are මෙතන අපිට තියෙනවා යුනිට්ස් වර්ග යුනිට්ස් කීපයක්. හරිද? දැන් මේක අපි කතා කරන්නේ same unit එක convert කරගන්න විදියක් නේ. Same actually this conversion. Here we convert the same unit into a small unit or large unit. So instead of instead of this case, we can use separate smaller unit. We can use separate large unit. Metric ton, metric ton. We can consider metric ton as an example. So metric ton means that is not kilogram. There is another larger unit. There is another larger unit which can be used to measure mass. So 1 metric ton is equal to 1000 kilogram. But that is another separate unit. That is another separate unit. It is something like feet, or we can use miles instead of kilograms. No? So we can use light years instead of kilograms. Kilometer. Kilometer instead of kilometer. Instead of kilometer, we can use miles. We can use light years. And those are separate units. Yeah, venom units put it. Make a couple more and part. After submultiples, actually, we need multiples and submultiples if we convert the same unit into a smaller or larger scale. And we need submultiples or multiples if we convert the same unit into a larger or a small scale. Otherwise, do not need. Is that clear? තේරෙනවද? හරිද? තීලිනා. Is that clear today? Hello, Therefore, normally prefix is needed when the same SI unit is converted into a large scale or a small scale. So, if we use a separate unit, if we use a separate unit, then we do not need to convert the SI unit into that way. අපි separate unit එකක් මේ use කරනවා නම් ඉතින් SI unit එක එකට convert කරන්න ඕනේ නේද පුතේ? හරි. අපි ඒක කතා කරනවා වෙනම. Okay. So if I consider prefix පුතේ, we can divide prefix into two categories, multiples and submultiples. Putte multiples means that is used to convert the SI scale into a large scale. Large scale. There is a multiplication. There's a multiplication. There's a multiplication. There's a division. Putte submultiples means there's a division. Okay. From that process, we can convert the SI scale into a large scale. SI scale into a large scale. Here, the SI scale into a small scale. A small scale. Okay, we can consider some factors. We can consider some factors that we can use here. What are the use factors here? Better. You know. Putte, K are multiples, yes. Okay. Deca. If we consider about deca, deca is a prefix putte. The symbol of deca is D8. D8. The factor is putte 10. The factor is 10. So decameter means meter is multiplied by 10. The meter is multiplied by 10. And if meter is multiplied by 10, if 1 meter is multiplied by 10, then it will be converted into 1 decameter. 1 decameter. This is the factor, okay? That means 1 meter, if 1 meter is multiplied by 10, it will be converted into 1 decameter. 1 decameter. Is that clear? තේරුණාද තුෂාන් පුතේ? Then hecto. Hecto means H. Actually, if you consider about multiples, it is very easy to remember පුතේ. මේ ටික විතරයි උඩ දෙක විතරයි මතක තියාගන්න තියෙන්නේ. පල්ලෙහාට මතක තියාගන්න ලේසි. How to remember? You know the capacity of computer. කොහොමද වෙන්නේ? මුලින් මොකද වෙන්නේ? kilobyte, then megabyte, gigabyte, terabyte. කොහොමද යන්නේ නේද? Therefore, you can remember like this, no? Kilobyte, then megabyte, then gigabyte, then terabyte. So after peta and hexa. Before the kilo, there are two deca and hexa. Hecto, deca and. Here, 100 means 10 to the power 2. Here 10 to the power 1 put then 10 to the power 2. 10 to the power 2. Therefore, if 1 meter is multiplied by 10 to the power 2, it will be hectometer. 1 hectometer. 1 hectometer. There should not be any space here. Whether is space here in the back. Then kilo means simple K. Symbol is simple K. Simple DA, simple H, simple K. The factor is 10 to the power 3. 10 to the power 3 means 1000. If I multiply 1 meter by 10 to the power 3, it will be equal to 1 kilometer. 1 kilometer. Is that clear? Then if it is clear, please raise your hand. Then mega. Mega means here capital L. The symbol is capital L. The reason we use capital M actually there are a lot of simple names. One is meter for meter. Other one is for millimeter. Therefore, we cannot use simple here. Therefore, that's why we use capital M. Mega. That is 10 to the power 6. So up to here, up to kilo, the power increases by 1 by 1. So after that, 3 by 3. ඒව ගන්න එපා මම මේ ඔය නෝකෙදි තියෙන ඕනෙද දේවල් හිතන්නේ. මම කම්පියුටර් ලැන්ග්වේජ් එක යූස් කරන්න කිව්වේ ඒකේ තියෙන දේ ගන්න කියන එක නෙවෙයි. අපි ඒකේ එකක් පස්සේ එකක් කොහොමද ආවේ කියලා පොළොට ගන්න කියන එක විතරයි මම කිව්වේ. කිලෝ වලට පස්සේ මෙගා එන්නේ, මෙගා වලට පස්සේ ගිගා එන්නේ, ගිගා වලට පස්සේ ටිකා එන්නේ. හරිද? මේකේ වැරදි පැත්තෙන් අල්ල ගන්න එපා හැමෝටම. හරි. Okay. Computer conversion is another thing. That is may depend on byte. මේක physical physics එකත් එක්ක එක යන්නේ නැහැ. හරි? ඒ වෙන standard එක. Okay. Then giga. Giga means with a capital G. Sorry. Here. If 1 meter is multiplied by 10 to the power 6, it will be converted into 1 gigameter. 1 gigameter. Tera. Sorry, giga, sorry. Here, mega. Mega. If 1 meter is multiplied with 10 to the power 6, it will be 1 megameter. Then giga. Giga is 10 to the power 9. If 1 meter is multiplied by 10 to the power 9, it will be equal to 1 gigameter. 1 gigameter. Tera, capital T. The factor is 10 to the power 12. If 1 meter, if the SI scale multiplied with 10 to the power 12, it will be converted into 1 terameter. Peta means capital P. Exa means capital E. And peta, the factor is 10 to the power 15. 10 to the power 15. You can easily remember. So up to here, 1, 2, 3. After that, it will increase us 3 by 3. If 1 meter is multiplied by 10 to the power 15, it will be converted into 1 petameter. Then, exa means 10 to the power 18, 10 to the power 18. Therefore, if 1 meter is multiplied by 10 to the power 18, it will be converted into 1 hexameter. Hexameter. Is that clear? If it is clear, please raise your hand. I need response from everyone. Okay. Okay. Then submultiples code. Submultiples. Okay, the first one. Here, G.C.E. First prefix is G.C.E. The symbol. Sorry. Then hecto. Sorry. Basic. Centi. Milli. Micro. nano pico femto මොකක්ද පුතේ? රිසල්ට් ඇවිල්ලාද? හරි හොඳයි වෙයි. හරි. femto, the next one is atom. Next one is atom. Desi. The symbol is simple E. Centi, simple C. Simple M. Micro means mu පුතේ mu. මෙන්න මේකේ mu. Mu කියලා කියන්නේ. Nano, simple N. Simple P. Simple F. Simple E. Simple E. The factor is පුතේ මේ වගේ තමයි. Deci means 10 to the power. Here පුතේ factor is -1 because this is a division no puti. This is a division. As it is a division, we write the factor as a -1. This is -1. Here the factor is -2 because this is a submultiple. Submultiple means there is a division puti. Therefore factor is in the denominator. To represent that one, the factor is represented by 10 to the power minus value. Is that clear? Here factor is -3 today. So as in the multiples, so up to here, the number, the factor will be -1, -2, -3. After this point, the factor will be increased by 3 by 3. Will be increased 3 by 3. 10 to the power -6, 10 to the power -9, 10 to the power -12, -15, -18. -18. Therefore, if I consider about 1 meter here, if I consider about 1 meter here, if I multiply 1 meter by 10 to the power -1, I can write it as 1 decimeter. 1 decimeter. 1 decimeter. Then, here, if I multiply 1 meter with 10 to the power -2, I can write it as 1 centimeter. 1 centimeter. Here, if I multiply 1 meter by 10 to the power -3, I can write it as 1 millimeter. 1 millimeter. Then, if I multiply 1 meter with 10 to the power -6, that is equal to 1 micrometer. 1 micrometer. Then if I multiply 1 meter with 10 to the power minus 9, it will be 1 nanometer. Right. So this is the new scale. New scale. So if I multiply 1 meter with 10 to the power minus 12, then the scale is converted into picometers. So that is equal to 1 picometers. Likewise, if I multiply with 10 to the power minus 15, it will be equal to 1 femtometer. Femtometer. Similarly, if I multiply with 10 to the power minus 18, it will be equal to 1 atometer. FMAL. Therefore, if we multiply the SI unit, if we multiply the SI unit by a suitable factor, it will be converted into a larger scale. The factor can be represented by an English letter. The factor which is used to multiply the SI scale can be represented by a English letter, and that English letter is called the prefix. The prefix. Therefore, the prefix has a symbol, that means English letter, as well as it has a value. It has a value. K, simple K means 10 to the power 3. Capital N means 10 to the power 6. Capital G means 10 to the power 9. Therefore, a prefix has a symbol as well as a value. And then not like actually not only multiples, there are submultiples too. Submultiples means dividing by a factor. Dividing by a factor means multiplying with a reciprocal. Division is equal to multiplication with reciprocal. Therefore, instead of division, I can write it as a multiple with the negative power. එහෙමයි. So මෙතන අර මේ එහෙම අර නීතියක් නැහැ. But if there's a capital prefix, normally it is in multiple section. In submultiple sections, there are only simple letters. But that is not a rule. That is not a rule because there are simple letters. There are simple letters in multiple sections. Multiple section is simple letters. Multiple section මේ capital දාලා submultiples වල simple දානවා කියලා නීතියක් නැහැ. There's no rule to represent submultiples in capital, and so there's no rule to represent multiples in capital and submultiples in simple. There's no rule. But as a practice, as a standard practice, normally we use capitals when it is necessary. We use capitals when it is necessary in multiple section only. හොමුතේ ඒක මං කියලා අපි දැන් මෙතන හිතන්න ඕන දැන් මිලිමීටර් කියලා ගන්නකො. දැන් මිලිමීටර් වලදී මිලි කියන එක represent කරන්න m use කරන්න ඕන. හරිද? ඊට පස්සේ මෙගාමීටර්ස් වලදී මෙගා කියන එක represent කරන්න m ඕන. m ඕන. ඒක මොකද්ද capital දාන්නේ? මෙයා capital දානවද මෙයා capital දානවද කියලා ප්‍රශ්නයක් තියෙනවනේ. අන්න ඒක නිසා ඒ වගේ වෙලාවදී අපි දාලා තියෙන්නේ multiple section එකට තමයි දාලා තියෙන්නේ capital C. හරි. ඒ වුණාට ඒක රූල් එකක් නෙමෙයි. ඒක රූල් එකක් නෙමෙයි. ඒක ස්ටෑන්ඩඩ් ප්‍රැක්ටිස් එකක් විතරයි. හරි. ඕකේ. ඒක රූල් එකක් වුණා නම් පුතේ මේවත් ඔක්කොම කැපිටල් වෙන්න බෑනේ. මේවත් කැපිටල් වෙන්න බෑ. ඒක කැපිටල් වෙන්නේ නැහැනේ. ඒක නිසා තමයි එහෙම තියෙන්නේ. ඕකේ. හරි. Is that clear පුතේ? Do you have any questions regarding prefix? Prefix ගැන මොනවා හරි questions තියෙනවද? හරි. Okay, from next week onwards, you will have a small paper before starting to the class. So I will send this paper at 1:30 p.m. 1:30 p.m. Then it will be a half an hour paper. So you have to answer that one. Then log into the class at 2 o'clock. Okay. So it will be our normal procedure from next week onward. From next week onward. Now we have enough theory parts to make a paper. Hi. Now the finally we have to we have to learn the rules. We have to learn the rules when writing a unit. Actually, there are special rules for it. Now we should learn that thing. Rules. Rules in writing units. So that is the last part of unit. Unit scale segment unit dimensions unit part together. It was a dimensions part together. Okay. Then the first one. The first rule is, suppose normally we have to write this unit with number. Number means that is the magnitude. Unit means that is the scale. Therefore, if you write a unit with a magnitude, there should be a space. There should be a space between the magnitude and the unit put in. There should be a space. If there is no space put in, if there is no space like that, that is wrong. That is wrong. Actually, you will be evaluated for this. Then second one. The second thing, Pute, if you write a unit, if you write a unit with a special name, if you write a unit with a special name, the first letter should be capital. The first letter should be capital. It is something like Newton. No, Newton, the first letter is capital. There's only one letter, therefore no need to worry about that thing. If we use, if we consider about Pascal, the first letter capital, the first letter capital, the other letter simple. Hertz, the first letter capital. Actually, first letter is capital when this unit represents a name of a scientist. A name of a scientist. If this unit represents a name of a scientist, the first letter should be a capital. And actually, this is SI unit with special names with it. Those are the SI unit with special names. First letter is capital. Capital. When the unit represents the name of a scientist. When the unit represents the name of a scientist. Third one. Suppose if the unit is a unit without a special name, if the unit is a unit without a special name, all the symbols should be simple. All the symbols should be simple except prefix. Prefix is simple. And if the unit is a unit without a special name, without a special name means something like kilogram per cubic meter. Then meter square. Then what else? Kilogram per cubic meter, meter square. Then meter cube. Likewise, if m is -1, if the unit is a unit without a special name, all the symbols should be simple unless it is a prefix. And prefix if you consider prefixes like mega, giga, tera, peta, exa, the symbols of those prefixes are capital. So except those symbols, all the other symbols should be simple. Is that clear? If it is clear, please raise your hand. Then the fourth one. Then the fourth rule. Okay. When you write a SI unit, when you are writing a SI unit with several units, put it something like this one. Kilogram per cubic meter, or m is -1, kilometer per hour. So in such cases, there should be a space. There should be a space. There should be a space between two units. Between two units, because kilogram is used to measure mass. No, meter is used to measure length. Meter is used to measure length. S is used to measure time. Therefore, there should be a gap between two units which are used to measure different physical quantities. Now, there should be a space. There should be space. Therefore, this is correct. But if you write this ms minus 1 like this, that is wrong. If you write ms minus 1 like this, that is totally wrong. Then the fifth part. When you are writing a prefix, when you are writing a prefix, prefix belongs to the same physical quantity. It is belong to the same physical quantity. Therefore, there is no space between a prefix and the main unit. Kilometer. Kilometer has to be written as like this. There should not be any gap between K and M, because both are belongs to the same physical quantity. Here, these two belongs to different physical quantities. That is the reason there is a space to separate those physical quantities. Here, kilometer means this is the prefix of meter. This is the prefix of meter. Therefore, this K belongs to M. So, there's no gap between a prefix and the main unit. There's no gap between prefix and the main unit. Kilometer, megameter, then gigameter. Those are correct. But if we write this one, kilometer like this is wrong. Is that clear? Here, nothing I keep with it. If it is clear, please raise your hand. Oh. Then, sixth one. When you write a unit in words, all the words should be simple. All the words should be simple. This is Newton. Therefore, Newton should be written as Newton. Here, kilograms per cubic meter. Here is square meter. All the letters should be simple. All the letters should be simple. Is that clear? If it is clear, please raise your hand. Those are the rules when writing. Those are the rules when writing a unit. If it is clear, please raise your hand. I need response from everyone. Okay, thank you. Okay, now I will give some questions. I will give some questions. I will give you some questions. Okay. The first question is the first question. Okay. Sorry. Questions based on rules of writing units. Questions based on rules of writing units. Question number one. Question number one. State state whether the following symbols are correct or wrong, according to the rules of writing units. Okay. Okay. Have you finished? Can we look at this one? If you finish, please raise your hand. If you finish, please raise your hand. Very good. Well done. Others? Oh, speed up, speed up. Shankar, speed kar. So once you finish, please give me a thumb. Okay. Have you completed? If you did all, please raise your hand. 1, 2, 3, 4. Ah, very good. That got you. Okay, now tell me whether it is right or wrong. Whether this is right or wrong. If it is right, please mark a right mark. Wrong, mark across. So it is wrong. What is the reason to wrong? What is the reason? What is the reason? What is the reason? Yes, there should be a gap or space between kilogram and meter cube. Yes, no gap here. No gap here. Very good, very good, very good. This one, second one, whether it is correct or wrong. Wrong. What is the reason? What is the reason? What is the reason? Here, the reason is gap. Gap. What is the reason? What is the reason? Yes, there is a space between the prefix and gram. Prefix and gram. How do you know this one is prefix? How do you know this one is prefix? It can be unit both. How do you know this is a prefix? Tell me. It can be a unit, no? How do you know this one is a prefix? Now tell me. Oh, the prefix key? No. Why? K is equal to Kelvin. Kelvin. Kelvin? Actually, K can be written for Kelvin. Therefore, how do you identify? How did you identify whether it is Kelvin or kilo? මේක කිලෝ කියලා ඔයගොල්ලෝ කියන්නේ කොහොමද? මට අන්නේ කියලා මට අන්නේ නේද? Yes, this is simple K. This is simple K. Simple K belongs to kilo, not Kelvin. Therefore, this is kilo. That's why this is a prefix. ඒක අනිවාර්යෙන් mark කරගන්න. අනිවාර්යෙන් mark කරන්න. You should mark that one. As this is a simple K, as this is simple K, as this is simple K, this one equals to kilo. So this one represents kilo. Otherwise, it will be Kelvin. Third one, whether it is right or wrong. Third one. Yes, it is right. It is right. This one. Yeah, that was right. Moira. This one. Yes, strong. One of the reason there is no gap. No gap between meter and yes. This one. Sixth one. Yes, that is right. This one. Seventh one. Newton meter. Newton meter. This is correct. Seventh one also correct. Seventh one also correct. You know this one, no? Joule. Joule per kilogram per Kelvin. Joule per kilogram per Kelvin. What is the unit? What is this unit put in? What is this unit? Unit of what? What? Unit of which physical quantity? Unit of which physical quantity put in? I know you have done this one. Yes, very good. Specific heat capacity. Very good put in. Very specific heat capacity. Alright, this one. Whether it is right or wrong. Whether it is right or wrong. Wrong. Hetua, reason, no gap. No gap. Ninth one. Whether it is right or wrong. Ninth one. Whether it is right or wrong. Then මොකද මේ හිර වුණා? Yes. Now you had to change your answer, okay? Then change करके an answer. Yes, very good, very good. You may learn something, okay? That's why you may mark that down. Yes, Ute, this is correct. This is correct. K is capital, therefore that is not. It is not a prefix. It is not a prefix. This is for Kelvin. Kelvin means I don't know what is the unit is, but symbolically it is correct. Symbolically it is correct. That is correct. No need to worry about the physical quantity. I don't know what is the physical quantity, but symbolically that is correct. Then, 10th one. 10th one. Why? What is the reason? What is the reason? What is the reason to encourage that team? What is the reason to encourage this? Need a space? Why? What is the reason to need a space? How do you exactly say this requires a space? How can you say this is meter? How can you say this is meter? How can you say this one represent meter? Is it mentioned here? Mentioned this is meter here? No, this can be milli. How do you identify whether it is milli or meter? Can you identify? No, you cannot identify. Okay, therefore, this might be correct. We cannot put it as rod because this may be millisecond. If it is millisecond, this is correct. This is millisecond. Okay, this is correct if it is millisecond. This is correct if it is millisecond. This is correct. And yes, that is the point. And so actually, if it is if you want to distinguish meter and milli, if you want to distinguish meter and milli, you have to think, or you have to think about the question very, very careful, because you cannot distinguish. We cannot distinguish, and that's why you have to write. That's why you have to write the symbols of SI units according to the rules. If you write SI units, according to the symbols, then only you can distinguish meter and milli. If you write this one according to the SI units, this one is millisecond. This one also correct. That is meter second. That is millisecond. If you write these two symbols according to the rules, then you can distinguish meter and milli. Otherwise, you cannot distinguish meter and milli. That is the importance of comply with the rules. And that is the importance of rules. So you have to follow the rules of writing SI units with it. Otherwise, you cannot distinguish SI unit something like meter and milli. Did you get my point? Therefore, both cases might be correct. Both cases might be correct. If it is correct, then this should be milliseconds. If it is correct, this one equals to meter seconds. Those are the two differences. Is that clear? If it is clear, please raise your hand. If it is clear, please raise your hand. Hey, Ronaldo, sir. Okay. You can write a special note. Okay. You can write a special note for these two. What will put there? No, okay. Meter second means meter second. Meter into second. Meter per second means meter divided by second. Meter second, there's a multiplication. Meter per second, there's a division. Meter second, meter per second means this one. Meter per second. Did you get my explanation, please? This is meter per second. Okay? Oh my God, right. Write down, write a special note there. No, we have to think, we have to write this unit according to our standard. Okay, I've done this thing. We should write SI units, we should write SI units. According to the given rules. According to the given rules. Otherwise, there may be some occasions. Otherwise, there may be some occasions that we cannot distinguish, main units and prefix. Main units and prefixes. That we cannot distinguish main units and prefixes. Okay. Okay with it. Now, your this tute. I have sent this tute mail to you. I will send it again. I will send it again. From this tute, actually you have to do the MCQs. You have to do the MCQ from the MCQ number 1 to MCQ number 19. 1 to 19. 1 to 19, there are some we have no question number 1 to 19, except question number 11 17 16 16 and 17. Question number 11 16 and 17. Okay, so you can do up to question number 19 except question number 11 16 and 17. Okay, so we have completed the theories of unit systems today. So we have to do some another units that can be used to measure some special physical quantities. Because when definite, actually there are a lot of questions based on that part. What are the different units that can be used to measure the same physical quantity? There are some very famous not SI units, very famous units that can be used to measure some special physical quantities. So those kind of questions asked again and again to check whether the students know that answer or not. Okay. Now today we can complete the class quickly because now it is 7:30. In next time is in our next Saturday class, we will start dimensional analysis part. Dimensional analysis part. අද අපිට ඒක පටන් ගන්න බැරුණා මම පටන් ගන්න හිටියේ පටන් ගන්න බැරුණා කමක් නැහැ මොකද මේ අද කට්ටිය පොඩ්ඩක් එහෙම වෙච්ච නිසාත් ඒකත් කමක් නැහැ මේ but next time we will start that part for them. Okay. Do you have any questions regarding that lesson, regarding today's lesson?